So now the last set of slides in this talk come from this recommender book, which we've taken slides from before, the basic introduction to recommender systems we got from this slide set. And now we come back to the slide set after these examples from Netflix and Yahoo and other discussions. And then we take that discussion of collaborative filtering, which is the dominant approach to recommender systems, almost by definition. And it is very well understood. It has been part of computer science for a long time, although its value has only recently increased enormously. I mean, I don't think 20 years ago collaborative filtering was viewed as a particularly critical algorithm. Now it's absolutely critical algorithm and is used to generate enormous amounts of money on the internet. And it is used by all the major sites. And as I said, it is relatively well understood. Although, as we've stressed before, we do not know what the sites really do. I told you there was an Amazon article in 2003. There ain't an Amazon article later than 2003. It's not one I know about. So we do not actually know how, in detail, these algorithms are used. And I'm sure in no serious site are simple collaborative filtering algorithms used. They use extremely sophisticated, complicated algorithms with all sorts of optimization determined by running these A/B tests continuously for years to look at hundreds and hundreds and thousands and millions, I don't know, huge numbers of optimizations. And the essential ideas, the one we've mentioned, we have these two types of ideas, the properties of objects, or we look at the key idea, which I don't know who invented this idea, that if you have a bunch of users looking at things, you have the ratings of those users. In the real world, when we just have bricks and mortar, those ratings were not enough of them, are not easy enough to get hold of to be terribly useful. But on the internet, we said 4 million ratings per day on Netflix, presumably many more on Amazon and things. Those ratings contain enormous amounts of information which can be used to drive these recommender engines. And we're using the ratings. Remember, they are in the simplest model, these vectors we're dealing with have components which are the ratings. So when users are the points in a space of items, then it is the ratings of the users, which are the components for each of the items. And that is the simplest collaborative filtering method, which gives you a quantitative measure of whether a user will like or dislike a new item, because you're based on what information we have on all the users, ranking all the items. We can sort of try to predict what a new user will like or dislike a particular item. And it will also give you ranked lists of items that you think a particular user should look at. And that presumably underlies, at least in the simplest case, what Amazon and Netflix do for you. So here we have some examples gone through in some detail. We have a user called Alice and an item not yet seen by Alice. Alice is a user. I is the item we're trying to rank. And the way we work is we find users who have rated this item we're trying to decide if Alice will like. And we also want these users to like the same items as Alice. So these users have some overlap with Alice. And so the basic intuition is clear. We're going to find users similar to Alice based on items that Alice and the users have ranked. And then we're going to use the rating of those users like Alice of a new item to be able to predict how Alice would like that item. And then we're going to do that for lots and lots of items and find the best. And this makes some probably plausible assumptions that users have some stability in their tastes. But I think that's plausible. I mean, it obviously will not. There's some circumstances when that breaks down, but I don't think it's a serious problem.